Hi guys, Qidi just released a new 3D printer model, the Q1 Pro. In this video, we will unbox, test and show all the pros and cons of this new model. You want to know all the details? Then stay tuned. Hi guys, welcome back. My name is Rui and this is the Rui Raptor YouTube channel. If you want to help us out, you can by giving this video a like and subscribe to the channel. You can also help by joining our Patreon page or by clicking on any of the affiliate links posted below in the video description. So, Qidi Tech released today one more 3D printer, the Q1 Pro. This new printer is a Core XY fully enclosed machine with plastic covers but with an internal metal frame. It comes 99% assembled. We only need to install the filament spool holder and remove the axis locks. The printing volume is 245 mm on all axes. The manufacturer also highlights the following features. Active chamber heating. This printer can heat up the chamber up to 60 degrees C. As for the heat bed, it can reach 120 degrees C. It has dual Z stepper motors and lead screws, and the bed platform moves on 4 linear rods, which provides increased stability. The print head is equipped with a high flow hot end with dual metal nozzle, and it can reach temperatures up to 350 degrees C. This means it can print with a big range of filaments, has a direct drive setup, and can print at high speeds. It's also equipped with a couple of filament sensors, one on the print head for runout detection and a second one next to the filament entry to detect filament angles. As for the leveling sensors, it's also equipped with a couple of sensors. It has a proximity probe on the print head and piezoelectric sensors on the bed. The drivers used on this printer are the TMC 2240, which were chosen to reduce the motion inertia, reduce the motor noise, and increase the motion speed. On the main board, it has a 64-bit controller, one 32GB eMMC memory module, a Wi-Fi module, and runs on Clipper. Inside the chamber, it has an internal light and camera for monitoring and time-lapse recording. Qidi also provides their slicer, but it's compatible with Orca slicer as well. As for the selling price, the plan was to sell this printer at 599 euros, but the manufacturer will make a launch promotion with the printer being sold at a lower price. Okay, so let's start with the unboxing. Inside the package and at the top, we can find the user manual, the spool holder parts, a spatula, a power cord, a small PLA filament sample, some tools and spare parts, a glue stick, and a USB flash drive. The printer comes nicely packed and wrapped inside a plastic bag. The front door and top cover also come inside a plastic bag. On the printer and all around, there are several stickers with warnings and instructions. Before turning the printer on, there are a few things we need to do first. There are a few axis locks that need to be removed. For the X and Y axis, we have a few zip ties that need to be cut. The print head comes protected with a small cardboard as well. The heat bed is also locked. To unlock it, we need to remove 4 screws marked by the stickers, 2 on each side. The print surface also comes inside a plastic bag that we need to remove. At the back of the chamber, we need to remove the small tape from the filament purge container. As we mentioned, the printer comes almost fully assembled. The only assembly we need to do is the filament spool holder. The filament spool holder is attached at the back on this block. It seems that the manufacturer's initial plan was to mount the shaft directly on the back panel. We guess they eventually changed the design so it could be attached with the long arm to the side. And this is how the printer looks like. At the front is the touch display and the front door. The display is a 4.3-inch touch color screen. The front door is made from plastic and it's held shut by a couple of magnets. At the back is the filament entry, an opening where the air will be pushed out, the filament spool holder, and at the bottom is the main power connector and the on and off switch. At the top is a removable plastic cover and a USB connector that can be used to plug in a flash drive. And this is the interior of the printer. As we already mentioned, the print surface is a flexible steel sheet with some texture and can be used on both sides. Although the printing area is 245 by 245, the print surface is 250 by 250 millimeters. The heat bed is surrounded by this plastic frame. The bed magnet is this entire black surface and it feels very strong, so it should hold the print surface very good. Under it, we can see the nuts to level the bed and some of the piezoelectric sensors. The bed should come aligned from the factory, so there is no need to adjust it. The heat bed moves on 4 linear rods, 2 on each side. There are also 2 stepper motors and lead screws moving it up and down. At the left side is the fan and chamber heater. At the right side is a large fan. This fan is for layer cooling when printing at high speeds. The air comes out from the top and is directed to the printing area. At the back is one more fan. This fan is pushing air out. However, it's weird not having an air filter here. The air is being pushed straight out. At the back is a filament purge container and a nozzle wiper. The container is used to collect filament purges before each print. It's transparent, so we can easily see when it's full, and it's easy to remove and reattach. The nozzle wiper is this mechanism that can move back and forth. It's the print head that makes it move. To clean the nozzle, there's a small felt piece, and this small metal piece. Behind the display, there's a camera. This camera has a resolution of 1080p, and with it, we can monitor the prints and make time-lapse videos. There's also an internal light behind the front panel. This light is basically a small strip of LEDs. The X and Y axis move on metal linear rods as well, and they are set up as core XY. The print head cover is secured by magnets, so it's easily removed. On the cover, we can see the layer cooling fan and fan duct. On the print head, we can see the hot end. It's a high flow model and it's secured by these 2 screws. There is a small fan at the side to cool down the hot end. Next to it is the proximity leveling sensor. And above the nozzle, we can see the extruder with metal dual gears. This extruder has a ratio of 8.9 to 1. Above the print head, we can see the filament runout sensor. The PTFE tube is secured at the top. The cable from the print head goes inside this cable chain all the way to the back. At the back is another filament sensor. This one will detect the filament tangles. All the main electronics are located at the back. After removing a few screws, we can take the back panel out and check it out. Right off the bat, we can identify the main board and the power supply. The power supply used has an output of 24 volts and 14.6 amps. And this is the main board. The drivers are located here under the blue heat sinks. The main chip is under this green heatsink, and next to it is the eMMC memory module. Connected to the USB ports are the Wi-Fi USB module, the USB extension cable, and the camera cable. One interesting aspect is that they included a system to adjust automatically the belt's tension. When needed, we only need to loosen the 2 pulley lock screws, and the spring mechanism should place the belts at the correct tension. When turning the printer on for the first time, we get a few initial setup options on the display. The first one is to select the language. Next, we get the instructions to remove all the zip ties in case you haven't done it yet. Next are the instructions to remove the screws from the bed as well. Finally, it will ask to load some filament and move the heat bed up. Once the filament was pushed in, we have to tell the machine to start heat up the nozzle. The filament is then pushed through the nozzle, and that's it. The initial setup is done. And that leads us to the main screen. On this screen we have the flash drive and Wi-Fi connected icons. Then is the 3MF image of the latest print. It also has the nozzle, bed and chamber temperature readings, light switch, sound switch, and the shutdown or reboot switch for the firmware. Under all that, there are 4 tabs. On the second tab, we can control the temperatures, control the cooling fans, load or unload filament, and push or pull filament in 3 different amounts. In the manual menu, we can check each axis coordinates, move each axis in 3 different amounts, home the axis, and disable the stepper motors. On the third tab, we can access the internal memory or the USB flash drive and choose the file to print. On the fourth tab and in settings, we can change the language, configure the Wi-Fi network, check the system and export log files. In after sales we have some instructions only. Then it's the automatic sleep timeout for the display, update the firmware, and restore everything to the factory settings. Although the initial setup has been done at startup, there are a couple of calibrations that need to be done before the first prints, and that should have been included in the introduction setup. Anyway, they can be found at this calibration menu. One of them is the leveling. It's possible to run this automatic leveling every time before each print or not, so it's a good idea to run this now so that the values are stored. When doing this, the printer will start by heating up the bed up to 60 degrees C, and then use both leveling sensors to automatically level the bed. When doing the proximity sensor probing, it probes the bed in a 6x6 matrix. The second calibration is the input shaping. This will make the print head vibrate at different frequencies so it can measure the oscillation and then compensate the resonance while printing. The final calibration is to adjust manually the bed, but, as we mentioned, the bed should come leveled already, so we don't need to run this. Instead of unload filament, this printer has a replace filament button, which is the same and used to unload only. When triggering this unload button, we are asked which temperature we want to use and should match the filament that is currently loaded. Then, it asks us to take the PTFE tube out from the print head and cut the filament. At this time, we can pull the filament out from the PTFE tube and attach the tube back on the print head. Next, the printer will heat up the nozzle to the temperature we have chosen a few seconds before, and once it reaches that temperature, it will extrude the remaining filament that was left inside the print head. As for the max bed temperature, the manufacturer states that it can reach 120 degrees C. We tested this with our thermal camera and we got a max reading of 114 degrees C, which is pretty close. For the first print, we decided to print the first layer test that can be found ready to print. What it does is print one layer on almost the entire print surface. And it's a good test to make sure the leveling calibration is correctly done. And in our case, it's perfect. The layer was printed perfectly throughout the entire surface. As for slicer software, we have 2 options. We can use the slicer from the manufacturer, or we can use Orca Slicer with the profiles provided by the manufacturer. To establish a connection between the printer and the slicer, and for Qidi Slicer, we need to go to printer settings and then this small gear icon. Then we need to enter the IP address that the printer acquired. We can check that IP address at any time in the network menu on the printer. In Qidi Slicer, we can find the printer if we browse for it. With the printer connected, we can now send the print files remotely and access the printer's Clipper page. In Orca Slicer, it's very similar. We need to click on this Wi-Fi icon and enter the IP address, followed by 2 points and 188, and then access the printer on the Device tab. One thing we notice is that after a power cycle, the printer might acquire a different IP address. And when that happens, we need to enter the new IP in the device settings in the slicer so it can be able to reconnect. Next, we sliced a few benches and printed them with different filament types. One of the features that the manufacturer highlights is the use of silent TMC stepper drivers. We measured the noise level while printing, and with the door and top cover closed, it measured around 64 decibels with the meter next to the printer. With the door and top cover open, it measured around 74 decibels with the meter next to the printer. Next, we printed some ripple cubes and input shaping models. To test the heater chamber, we printed a large model with ASA filament to test if it would warp. We also tested printing with PACF filament. Then, we printed several models with PLA filament. While printing, we also made a few time-lapse videos. To enable the time-lapse videos, we first need to add a command in the G-code time-lapse area. And then in Clipper and under time-lapse, we enable it here. This is how they turned out. When printing filaments such as ABS, nylon, and others, they can release toxic fumes or particles into the air. That's why an air filter is important on these type of printers. Since the Key 1 Pro does not have one, we decided to use one of our air purifiers. However, the back panel does not offer many options to attach a hose or design an adapter for it. We had to stick with a low-quality solution to hold the hose in place. As for the test prints, here are the results. For the PLA Benchy tests, we printed 3 of them. One is the fast print that takes 18 minutes and it was already sliced by the manufacturer. Then we have a Benchy sliced with Qidi Slicer and took 33 minutes to print. And one sliced with Orca Slicer and which took 34 minutes to print. The one that was already sliced and took 18 minutes to print does not look bad. Aside from some issues related with the filament settings, we only point out some small amount of ripple effects. The one sliced with Qidi Slicer and took 33 minutes to print was the worst one. We can see much more ripple on this model and other issues caused by slicer settings. The one from Orca Slicer, and which took 34 minutes, was a bit better, but we still see some ripple markings. The tests done with the Ripple Test Cube show that the one printed slower is worse than the one printed faster. The main difference between these two is the outer and inner wall speeds. The explanation for this to happen is because the resonance is more noticeable at lower speeds, so increasing the speed will help to reduce this effect. The same result was found when printing the input shaping test model. The one printed faster was the one that got better results. Nevertheless, there is still a little bit of ghosting on the model. We also printed several benches with other types of filament. This one was printed with ABS, this one was printed with PETG, and this one was printed with ASA. To print with ASA, we had to heat up the chamber up to 55 degrees C. The result is this nice benchy. We then tested a print that would fill most of the print bed, and again with ASA filament. We had no issues with warping whatsoever. However, we must say that we had to use an adhesion promoter for every filament except for PLA. The print surface can hold the PLA very nicely, and when cold, it releases the model automatically. As for the PACF print, it's also okay. The layers are well bonded between each other, and overall we cannot find any problems. We did more prints with PLA filament, and they all turned out great. Okay, now let's check all the pros and cons. And for the positive side, we have the price. We think that for the features that this printer has, the price is fair. It's almost fully assembled. We only need to remove the locking zip ties and screws and then attach the spool holder so the printer will be ready to print in just a few minutes. It's a Core XY machine built on an internal metal frame. It's fully enclosed and the chamber can be heated up to 60 degrees C. Some calibrations such as bed leveling, which includes the Z offset, and input shaping are done automatically. The printer is equipped with two types of bed leveling sensors, vibration compensation sensor, and a couple of filament sensors. It's also equipped with an internal camera and light. As for printing surface, it has a magnetic steel sheet with a little bit of texture. The heat bed can reach 120 degrees C and the magnets are very strong, which is good to prevent the print surface to warp while printing large models. The nozzle is a dual metal model and we can heat it up to 350 degrees C, which means we can print with lots of filament types including the more demanding ones. There's a nozzle wiper and filament purge container inside. The display is nice and the menus are user-friendly. It has a very good amount of internal memory to store time lapses, print files, and whatnot. The printer runs on Clipper and we have access to it. And of course, we can access it remotely and monitor the prints through Wi-Fi connection. Qidi also offers their own slicer and profiles. The profiles are also available for Orca Slicer. The printing quality is good and it can print at high speeds. And for the negative side, we have one of the key features of this machine is the fact that it uses TMC silent drivers. However, the machine still makes some amount of noise while printing. This noise comes from the axis moving and also from the fans. When printing with PLA, where you need to keep the door and top cover open, this noise will be a bit higher. The top plastic cover in our case does not sit flat on the top of the printer, mainly because it's completely warped. The front door is missing a handle to open it. There's a sticker that says open, but we cannot get a grip to hold it. Whenever we want to open the door, we use the bottom corner curve, which is much easier. The filament unload procedure can be a little concerning because we need to remove the PTFE tube and cut the filament before we can remove it. Not sure if the PTFE tube lock ring will keep holding strong after a certain number of removals. We would prefer to have an automatic cutter inside the print head instead. The on and off switch is located at the back, and worse than that, is located after the power cord, which makes it difficult to reach. And the USB connector is located at the back, which does not make much sense. It would be better to have the USB connector at the front instead. The side panels have an area that looks like handles, where we can use to hold the printer when moving it. However, it makes a ramp, and this might cause the hands to slip. This printer was designed to work with many different types of filaments, including some harsh ones. Most of these release toxic fumes or particles into the air. It's important to have an air filter to prevent these fumes or particles to reach the user. However, this machine is not equipped with one, which is a negative point. And finally, although it can print very fast and has vibration compensation calibration, we still see a little bit of wavy walls on some of the models created from the ripple effect. So, these are the pros and cons. In a nutshell, the printer has good key features and can print nicely at high speeds. However, the profiles need to be tweaked for better results, and the vibration compensation could be a little bit better. And that's it, you guys. Thanks for watching. Feel free to leave your comments down below. We will see you guys next time. Bye!